Hey everyone, and welcome to another weekend hangout on air, powered by Radio Shack. Today we'll be talking about the LM386 audio amplifier. We're joined today with Nick Normal. How's it going, Nick Normal, associate editor at Make Magazine, and as always, Sam Freeman's hanging out with us at the Make HQ, intern wrangler extraordinaire. How's it going, Sam?
Not bad. How you doing?
Good, thanks. So yeah, guys, today we'll be talking about the LM386. It's a great audio amplifier. It's used in 3 projects that we've done so far for the weekend project series. The bass bump headphones amplifier, the infrared string bass, and the monobox powered speaker. So we'll be going over those 3 projects today. But before we do, we could talk about sort of what this little integrated circuit is doing and why it's kind of so prevalent. You know, it's really great for audio amplification and some schematics that you could find out there that are pretty common. The little smoky amp, it's great for using with like an electric guitar. And then another step up from there is, see, the little gem, and that sort of adds volume and gain control. And then if you go one step further and you do some input buffering to kind of tweak the signal, you can use what's referred to as the Ruby. And we'll put links to all the schematics after the Hangout in the comments below. And I should also mention too, you know, we have comments going on, so if you have questions for us during the Hangout, go ahead and shoot them to us. We'll try to answer those when we can. But maybe Nick Normal, should we go into the bass bump headphones? Sam, I think you have a working copy that you can show off, and we've got some screenshots to share.
Ah, cool. That'll probably have a lot less glare on them. Yeah. But this is our working copy of the bass bump headphone amp. It boosts the low frequency spectrum of your audio signal, and works for headphones or small PC speakers.
And it's great because here's like a blown-up view of the internals. You basically build 2 of these circuits on 2 perf boards that you can get all the parts at Radio Shack. Just find them real easily. And it uses basically capacitors and resistors, and you can control both channels with different knobs.
Yeah. So it's actually kind of cool that Radio Shack sells the perf board for the IC as a set of 2. And so you can see just in the lower corner there, instead of breaking them up and using them twice, you just built each channel on the same board and just mirrored the circuit.
And then the schematic, we can bring that up too. I thought actually this project I was looking it over is a really good test if you're ready to tackle sort of like an intermediate project. Let's see, throw up the schematic here. Like Sam said, you build 2 of the same circuits essentially. And so the way it kind of works, if we kind of like step through the circuit at least, is you break up the signal that's coming in from your MP3 player, some portable device, and you basically break it up at about 100 hertz frequency. And so there's a high signal and a low signal, and those both go through their respective high and low bandwidth filters, filters, the RC circuits. And then you actually recombine those signals once they've been filtered, depending on how you control your knobs, and then you can send that to the LM386 amplifier, and that just amplifies the sound to go out through your speakers. So it's actually a cool combination of filtering and then actually recombining the signals to get the final effect. So
yeah, so you're going to get a boost no matter what because of the LM386 right there.
And then there's, Sam, I guess we have a couple ways to mount it. You've got 2 examples. We could show those off.
Yep, yeah. So here's the quick and simple way to do it. Stick it in a Radio Shack project box. Put a couple of knobs on one side. Route the jacks cleanly through some grommets there. And then your power, so you can power it from an internal battery with the plug, or you can plug in an external power socket right there. Or if you really want to show off your handiwork, you can do this really cool clear acrylic enclosure. Yeah, it has a lower profile too when you put on some heavy-duty knobs.
Yeah, it looks like there's a switch on there too.
Yeah. So on the original one, I think he just wanted the most robust option possible. And since occasionally switches are known to break, he just had it plug it in and it's on, unplug it and it's off, and it's pretty idiot-proof right there. But yeah, in this version, he decided to actually throw in a switch for your power selection.
And we can mention too that the author of the article, Ross Hirschberger, he designed this circuit as well as one of the other projects we'll talk about, the string bass, the infrared string bass. And so I think in his comments initially he was saying, switches can be really prone to breaking, and so on the original project with the Radio Shack enclosure, it wasn't included, and the way you turn off the power essentially is you unplug your input jack. Is that right, Sam? So it's kind of a cool, when you're getting ready to carry it away, instead of having a switch or something, just unpull your plugs. It doesn't drain the battery. Although, one thing that's great about the LM386 is it's super low power. If you look up in the Texas Instruments datasheet, you can see that the minimal operating current draw is something, or power draw is something like 4 millivolts. So even if you do forget to disconnect or turn off the power switch, it'll last a couple hours. It won't totally kill your batteries.
Yeah, you're probably not going to notice a lot of draw just from the chip itself.
Yeah. And then as the second example Sam showed with the clear case, you can see the rechargeable batteries inside. So you can actually could be a hassle to take it apart again. At least with the build, you could use a rechargeable battery. So it's kind of a nice touch.
Yeah.
That was a cool project.
Definitely, yeah. So you never have to disassemble. In this case, you put all the time and effort into building.
Right.
And that's actually what the switch does, is it's either on or it's in charging mode.
That's
And
smart.
off just means that you can plug in power through your homemade USB cable and charge it up.
Awesome. So that's one application that we use the chip in. Another project that we did was the infrared string base. I could throw up some screenshots of that too. Maybe Nick Normal, you want to kind of mention some of that?
Sure.
Here we go. Can you see that okay?
Yeah, so this is the final version of the project, and you can see it's got sort of 3 home etched printed circuit boards, and the main circuit is housed in that sort of notch on the wood next to the 9-volt battery. It's accompanied by the other 2 circuits that are mounted between those threaded bolts there that sort of make that the strings are passing through. Those are infrared emitter and detector diodes.
Okay.
So basically, the IR is emitting out of the emitter diode, coming back in through the detector diode, going through the main circuit, which has sort of variable pots for each of the IRs, so you can fine tune them to the frequency that you need. And then the LM386 doing all the op amp work and outputting the audio. And you can see the turnbuckles as well on the wood sort of allow you to also fine tune the frequency of the vibration of the string is actually what disrupts the IR emitter frequency to generate the tune of the audio that you're playing. So yeah, very neat project, very fun. Sort of a little advanced because you have to home etch your own circuit boards, but
right.
Yeah, totally cool.
And then we can also throw up too. It's also another kind of a similar circuit. I mean, most of these circuits are really kind of similar once you get the basics. The LM386, you can control the gain by adjusting the basically a value in between pins 1 and 8, usually using a resistor or a capacitor resistor in combination. So initially the chip is set to have a gain of about 20. And then you can actually customize that up to 200 depending on different configurations. So
yeah, it's pretty good range.
Yeah,
really intense, and pretty amazing that it's able to do that from such a small package too. Yeah. So this is the infrared string base circuit.
Pretty standard.
Pretty standard, pretty simple, and yeah.
Cool. So then kind of the third project that we could talk about is the monobox powered speaker. That's always a good one. Nice portable box you can bring out camping or when you're barbecuing, just hook up your MP3 player. It uses batteries again, and you can also plug it in with the wall wart to power it. But I think Sam's got an example behind him, and Nick, you have the circuit you actually see in real life.
Yeah, so I've got the box here, and that's a really good point about both the portability of this project. Like you've mentioned, it can run from 4 to 12 volts. So in this case here, I've got it powered up by a 9-volt battery, but you could just as well plug it into your car's 12-volt adapter. So if you wanted to, be driving en route somewhere, you've also got portability there. And this thing can really blast. I won't turn it up all the way tonight.
Okay.
And I'll show you the circuit in a bit. So this is just turn it on here, and
I mean, it's great because the project shows you how to make the circuit, and then like Nick put it in a really cool
Yeah.
box.
What's really amazing about this project in particular is just how crisp the audio is, both the low and the high frequencies and the mids.
Okay.
It's just a really great sound. This isn't filled with any sort of foam or anything, so,
Oh, really?
so it sounds a little hollow to me right now. I don't know what you guys can hear over the net, but if you were to fill it with foam, it's got an even more sort of solid body to it. It sounds
Yeah,
really
I know
great.
we had a version of that where we did fill it with some polyester batting, I think.
Yeah.
And that improves
Yeah, and
sound
it was
quality
sort of even
quite a
more of a solid sound.
So let me just de-plug these things here and see if I can show you what we got on screen. So this is a standard, 8-ohm speaker.
Okay.
And then back there in the bottom of the box is the circuit, the power plug, and the audio input. And the circuit, again, pretty amazing because it's about 12 components. And it's built on that same butterfly circuit board that the
Okay.
bass bump headphone amp is, but this is only one of those two sides. So you very well could. So this is mono. That's the other point. But you very well could double this up and make it stereo. But it sounds just fine in mono. For most applications. I mean, again, barbecue, going to the beach, whatever.
Here's a screenshot of the kind of a zoom in of the circuit. You can see from Nick's example, like the circuit is a really small physical component in like this project. You can put it in boxes, different containers, different size speakers, but you can just make this one amp and really just power different speakers and power sources, and then find ways to embed them in different kind of cases. So that's the fun part, I think, for me is like you do the electronics and you get your circuit working, and then there's a whole other side of the project where you actually, how can you embed it, or how can you put it in a really cool wooden enclosure, or make your own crafted box. So, another great project to do on the weekends, and all the parts you can get at Radio Shack. Real simple, just pick them up.
This is this version of the mono box is inside of a Churchill Havana Reserve cigar box. It's been cut and fitted with this nice cloth grill. But there was a maker last year that built the mono box inside of a biscuit tin, and so it had a cylindrical shape to it. And,
okay.
Was a little bit of a different portability form factor. So yeah, like you say, very very versatile. You can build it into whatever you've got laying around that you otherwise thought you'd have to chuck, and then you've got a portable speaker.
Yeah, I'm kind of thinking it's such a cool platform, like the LM386. It's kind of, at least I'm thinking of, kind of parallel to like a 555 timer chip. Like once you sort of understand how they work and how they operate, you can really see a bunch of different applications for it. I mean, you can go so far as to include adjusting the gain with this circuit, and then also adjusting the volume, and you can play with those two combinations just with potentiometers and really fine-tune the sound for the specific box that you have it in, or maybe you're at the beach, it's really windy that day, you can really crank up the power. It says something like 0.5 watt power output for this little chip, so that's pretty good, for a portable stereo system, if you made 2 of them at least. And then I think you can actually bridge them together. You can use 2 of these chips together and get 1 watt of power out, make an even bigger amp. So tons of great applications for it.
Yeah, Marshall actually built a practice amp. So it's a total just portable, it's a tiny, tiny portable practice amp. And built by a name brand, audio manufacturer. And it uses a variation of the LM386 that's not dual inline, it's single inline. And so like that's just proof of concept that it's a very capable chip. Like you say, it's probably the equivalent of the 555 for audio applications.
Yeah.
For learning.
I was also looking up, because the Texas Instruments has a great data sheet out there with all of the kind of like basic stats, and I was really surprised. They show you, I believe it's like 4 to 6 basic circuits that you could do for different applications. And I jotted some down because, I hear it's frequently used for audio applications, but, they were saying AM, FM amplifier, an intercom system, a TV sound system, ultrasonic driver. So I was thinking maybe you could try to integrate like an ultrasonic kind of rangefinder if you had like a receiving end to do that. It'd be like a cool robotics application.
Cool.
And then it was also a small servo driver. So even if you're not into the audio, it could be worthwhile to look into like the mechanical.
That's pretty wicked.
Yeah, aspect of it, and then like power converters. So it's cool, and there's tons of circuits out there on the web. Just like do a Google search, you find tons of resources, free circuits, great step-by-step instructions. The weekend projects, obviously.
That's actually a really great segue, though, Nick. I wanted to give a shout out to a couple people. Obviously, Ross Hirschberger, who couldn't join us today. He's fixing a laser in South Carolina.
Right.
But thanks for him and all the work that he's done with the Weekend Project series. Also wanted to thank Addie and Whisker, aka the Toy Makers. They have a bunch of really great sort of how-tos online, specifically for learning about the LM386. And they even walk through and they break down that Texas Instruments data sheet sort of step by step, and they like really sort of deconstruct it for learning purposes. So they talk about device dissipation, voltage gain versus frequency, so on and so forth. It's really, really fun if you're and it's really plain speak. It's really easy to learn. So for sure visit their website. They're tymkrs.com, toymakers.com without the vowels. So.
Yeah, and then like I said, we'll be posting a bunch of links at the end of the Hangout in the comments. If you have some more questions about these specific projects that we've been mentioning, or some of the similar circuits like the Smoky Amp circuit, the Ruby, great place to start. So please, keep us posted on what you guys are building. If you have questions, feel free to ask them. And there's always the Weekend Projects page. Nick and Sam, anything else before we tune off?
We won't be here next week, so have a great holiday week next week, and we'll see you in the first Friday of December.
Yeah, so Sam, Nick, thanks for joining us today for the Weekend Projects Hangout on Air, powered by Radio Shack. We'll see everybody in 2 weeks.
All right, take care.
Thanks, Nick.